Hello everyone. Today we will discuss about page replacement policies. We have many page replacement policies. So here each one. So first thing we have least recently used, is also called as LRU. Then we have optimal algorithm. Then first in, first out. That is also called as FIFO. Then we have least frequently used, that is LFU. Circular FIFO, that is circular first in, first out. Then we have random replacement. I hope all you have learned these paging algorithms earlier segment, but still, since it is a part of your syllabus, we will learn each page different policies. So first we will discuss about LRU, least recently used, and FIFO technique. So we have two level memory, has 4 page frames in main memory. A certain program generated the following page trace. So we have the page trace. So now we are trying to compare LRU with FIFO. So observe here. So we have 4 memory frames. So if you observe here, 2 level memory system has 4 page frames. Okay. So what we are trying to do is, we are trying to insert pages to the virtual memory. Sorry, to the main memory. So we have various page traces. First, what we will try to do is, we are trying to insert 1. So there is initially the memory is empty, so there is no problem. So we are inserting 1. After that we are inserting second page, because after 1 we have 2, so we are inserting second one. Then we are inserting 3, then we are inserting 4. Now the memory is full. Okay. So initially we will try to insert 1. So 1, and this arrow indicates least recently used. So this always points to least recently used page. Then we try to insert 2. Then if you see 2 here, so we are inserting 2, but 1 is recently used. Similarly, if you next is 3 here, we are inserting 3. Then so we're inserting 3 also here. It's because there is free space here. And next we are trying to insert 4, and if you see here 4 we are inserting, again there is free memory space, so there is no problem. So 1 is least recently used, so arrow mark always denotes recently used. Next we are trying to execute 2, and if you see here this 2, so this 2 is already, it is in the memory. So what we will do, so there is no problem, so it is already there, no problem. So we keep the memory as it is. Next we will go to 1, and if you see here 1, so 1 is also, it is in the there, so no problem. And if you observe here, since 1 was recently used, now we are changing the least recently pointed to 3, because 2 is also used here. So now we are changing from pointer 1 to, so from here this to this. Okay, because 3 is now recently used, because 2 is also used now recently, but least recently used other than 1 was now 3. Now we are trying to insert 5, and if you see here 5 is there, and if you come to 5, it is not there in the memory, so I have to replace this 3 with 5. Okay, so we are removing the 3 here, and we are inserting 5 in the place of 3 because this pointer is pointing to 3. Now again we have to change the pointer because now 4 is least recently used, so the arrow mark is changed here. Next we are trying to insert 6, and if you observe here 6 is not in the memory, so we have to replace 4 with 6, and we have to change the pointer to 2 because 2 was now least recently used. Now we are trying to insert 2, so 2 is already there, no problem, but the pointer we have to change because now 2 is used, so we have to change the pointer to 1. And next we are trying to insert 1. 1 is also present. Now again 1 is pointing, so 1 is least recently used. Since 1 is used, again it is used. Now we have to change the pointer to 5 because it is now least recently used. Now we are trying to insert 2, so 2 is already there, no problem, no changes because 5 was least recently used. So now we are trying to insert 3, and if you observe 3 is not in the list, so we are replacing 5 with 3 here. Okay, similarly we are trying to insert, and now pointer should point to 6 because 6 is not least recently used. Similarly we try to insert 7. 7 is not there, so we replace 6 with 7. Now pointer has to change to 1. Similarly we are trying to insert 6. 6, if you see here, it is not in the memory, but we have to replace wherever the arrow is pointing, so we have replaced 1 with 6. Now next least recently used rather than 1 was 2, so we change the pointer to 2. Now we are trying to insert 3. 3 is already present, no problem, so no changes. If you observe here, no changes. Next we are trying to insert 2. So if you observe 2 is already in the memory, but the pointer is pointing to the 2, so we have to change this pointer to least recently used item. So page, now it is to 7. And similarly we have next we are trying to insert 1. 1 is not there, we are replacing 7 with 1 and changing the pointer to 6. Now we are trying to insert 2. If you observe 2, so it is already there, so no problem. And again we are trying to insert 3, no problem. Now we are trying to insert 6. 6 is already there, but pointer has to be changed. This is how your least recently used memory model works.